A voltage amplifier question. This one's backwards to what you normally see. They normally give you a graph that looks like and you have to, given this, make this graph here. So they've given you these two and you're going to end up making this graph here. So it's a bit backwards than what we normally see, but we should still be able to solve it. So this is the input signal, here's the output signal. So they give this signal in, it goes through the amplifier, and this is what it gives out. So it turns this value at 5 milliseconds, it turns into this value. At 10 milliseconds, it turns this value into this value. And you can see that this is clipped along here, from this section here to this section here. It's clipped. The first question is asking us, what's the voltage gain? So what's the gain in the amplifier in the linear region? That means when it's not clipped. So we can't pick any values where it's flat. The last value before it's clipped is this value here. Let's do it in red. That's the last value we can look at. So this gets turned into that value there. Let's do the calculation. So it goes from 200 millivolts. Make sure you get that unit. 200 millivolts into minus 10 volts. So that's 0.2 volts to minus 10 volts. So it increases. What's the gain? The way we work it out is minus 10 divided by 0.2 minus 50. You put your answer as plus or minus 50. I mean, if you put your answer as plus, they'll still mark it right, and minus is still right as well. So the gain is minus, am I right, minus 50 times. Oh, not volts. It's not volts, it's times, because it's the gain. Oh, wrong question. Alright, now in this question they want us to sketch the voltage characteristics. This is, they want us to do this graph that looks like that, or that. Include a scale on both axes, so we have to put the scale in as well. Right, I've copied and pasted what we've got over here to make it easier. We've just got to do what turns into what. So we know 200 millivolts turns into minus 10, so that's one of the ones I'm going to put in. 100 millivolts turns into minus 5. Put those ones in first. So I'm going to spread this out. This is going to be my 100. This is going to be my 200. Here's my 300. This is going to be my minus 100. Minus 200. Just so you can read it, that says 100. And this is my minus 300. Here's my 5. Here's my 10. Here's my minus 5. Here's my minus 10. Do it in green so we can really see it. Alright, 100 millivolts turns into minus 5. How do I know that? Because I say this point on the graph between 0 and 5 is the same as this point on the graph between 0 and 5. That's there, and that's there. So 100 millivolts turns into minus 5. 100 millivolts here turns into minus 5. At 5 milliseconds on the graph, we've got 200 millivolts. At 5 milliseconds on the graph, we've got minus 10. So 200 millivolts turns into minus 10. 200 millivolts turns into minus 10. At 10 milliseconds on the graph, we have this 300 millivolts. At 10 milliseconds on the graph, we have still at minus 10. This is where it gets clipped. So 300 turns into minus 10 as well. And we can go through the other side. At 22 or something, minus 100, 22 positive 5. So minus 100 millivolts, minus 100 millivolts turns into positive 5. You can see where this is going. Minus 200 would turn into minus 10, and just like before, minus 300 is also 10. So that is nice. You'll use a ruler to do this. Nice straight region, and this is our clipped region. And clip. The last thing we have to do now is make sure we put our units on here. The units for this one is volts. I like putting my units in brackets so you can clearly see there's a label. The units are in brackets, and the units on this one is millivolts.